My name is David Russell, and I'm a developer here at Itasca Consulting Group, and this is a brief demonstration of PFC3D, the enhanced visualization version. I'm going to be demonstrating a new user interface that focuses mostly on plotting, but offers some other benefits as well. The first thing you'll see when you load the code is the startup options. What I'm going to do is open last project, which, assuming you've been working on a project, it will be able to bring up the last project you were working on. And continue where you were. The user interface is populated by what we call panes. The definition of pane is essentially a window that contains something. In this particular case, there's the console pane down here, which is familiar to people who use PFC. It contains both a prompt where you can type in commands and the text output that shows the results of those commands as they're processed. Up here is an edit pane. This is a built-in text editor that allows you to create data files that can be loaded into PFC. Here is a tab as a plotting pane, which is a built-in plotting window that you might be familiar with from earlier versions of PFC. To the right is a control panel currently used only to provide controls for the plotting pane. And over here is what we call a project pane, which provides some basic project controls to allow you to control and organize the files that make up your PFC project. You have a fair amount of control over how your panes are laid out. And to give you some help with that, we offer a layout menu. By default, PFC launches in what we call horizontal layout, which might be familiar to people who use 3D. In this case, text-based panes are on the left and plotting-based are on the right. You can switch to vertical, in which case plotting and editing is on top, and the console pane and project panes are on bottom, and the control panel is on the right. Single, all the panes except for the control panel are tabbed in the center, and then my personal favorite, wide, has editing and plotting here, the console below, the project pane to the left, and the control panel to the right. You'll notice that there is a toolbar up on top. This is a context-sensitive toolbar. The contents of these toolbar tab buttons depend on which pane is active. For instance, if an editor pane is active, then editor tool buttons appear up here. If the plotting pane is active, then plotting buttons appear up here, and so on and so forth. In addition to the preset layouts, PFC's new user interface allows you to move the panes in any layout you want. For instance, I can grab this base view and move it to the right of the editor so I can see both at once. I can create a new view, tab it into the same one, or move it to the right as well to see all three at the same time. I can move this over here on the bottom, or tab it into the console pane. I can pretty much arrange things in any way I want. I can also, once I find a layout that works the way I desire, save that layout explicitly to restore later. Layouts are also automatically saved as part of a project file. So if you have a layout that works for a particular project, that layout will be restored when you save the project. In the Tools menu, there is an Options dialog box that summarizes most of the global settings available to PFC-EV. A lot of these control how the user interface appears to the user. Notice you can change things like the customer title that appears at the bottom of the legend and plot windows, the job title for the particular save file, what notices appear in the console window during the course of running a data file. You can change the appearance of the console window, how much text is saved, the font that's used, the color of the text. You can change the behavior of the code at startup, whether it shows the dialog or whether it automatically opens the last project. You can change the fonts and the syntax highlighting used in the editor window. You can change most of the default behavior for plotting windows as well. And there's movie controls that I'll be going into later here as well. And lastly, there is help options available. And if you just select the basic help window, you will see some extensive user interface help to remind you of how to navigate the new user interface should you need to be reminded. One of the things we've added to the PFC user interface is the concept of a project. A project is essentially our way of helping you organize the files involved in your PFC model. Those files, as you can see in the project pane, are the data files that you use to describe your model, the save states that your models create, and the plot files that you use to view your model. If you go to the File menu, you see the top part is devoted to project files themselves. You can create a new project, open an existing project, save your project, and close your project to reset it. The middle part lets you add new files or items to your project. For instance, I can create a new data file and add it to the project here and give it a name. And this lets me add a new data file to the project. And that will appear here, and I can switch between them. I can also, by opening an item, add an already existing data file to the project. Here, cave2.dat. The project pane offers more than just a simple list of which files are involved in the project, and also offers a way for you to interact with those files. For instance, if you double-click on a data file in the data files section, it brings that data file up in a pane for you to edit. If you right-click on an entry in the data files section, it gives you a list of options. You can open, which is the same as double-clicking. You can close it. You can remove it from the project, you can delete it entirely, and you can actually open it in Explorer, which brings up the folder in the Windows folder system. If it's a save state and you double-click on it, it actually restores that save file, which lets you see that save state and the plots of that save state in your system. And if it's a plot file, it brings that particular plot file up. Most of the other context menus are exactly the same. The data file editor that's built into PFC has syntax highlighting keyed to PFC's command structure. So it's tuned to commands, strings, integers, floating point, and fish in such a way to give you feedback as to what you're doing. It also has one of the tools available is a big green execute button that executes the data file you're working on within PFC, which people find very convenient. Here in the console window, which you can maximize if you wish to see more of what you're doing. If you give a print command, for instance, print ball, that, if there's a lot of it, will go into a separate tab. Here, you can see the result of it all at once and scroll up and down. You can, with this button, save that to a file, or you can just get rid of it and move on and print something else later. Now let's focus on the new plotting capabilities of PFC-EV. Here is a plot pane, and here is the control pane that controls the plot pane. In the List tab, we see the list of plot items that are available to put into a plot view. If we do a ball geometry plot, we can see the balls that are part of this cave project. Let's add as well a wall geometry plot. Since balls are rigid and contacts are soft, we can see, for instance, that typically balls penetrate slightly into walls. As you can see, simply by grabbing and moving the mouse, we can rotate our model around to view it from all angles. The standard view controls are left mouse button click and drag to rotate the model around, right mouse button click and drag to translate the model around, and if we hold down the control key and do a left mouse button click and drag, we can rotate about the center axis of rotation. The control panel is filled with 3 control sets. This top control set is the list of plot items that are available. So we've added a ball plot item and a wall plot item. This allows you to control the legend. This is controls for this particular plot display, and this is controls for all displays. When you click on one of these items, attributes for that item appear in this attribute tab down below. For instance, in a ball plot, I might go to the colors attribute and change the colors of the balls to green or a pale pink. I can change their smoothing quality or render them transparently. When I click on the legend item, you'll notice that over here on the left side, the legend is highlighted in red with black boxes indicating control points. That indicates that aspects of the plot are directly manipulable. If I move my mouse over to that region, the mouse will change to a hand, indicating that I can now drag the legend and move it anywhere I want. For instance, I can move it to dock it on the right, or I can simply leave it floating somewhere in the model. I can also grab these control points to resize the legend any way I want. I can also directly edit those aspects of it here in the attributes and change other attributes by directly editing these properties. I can go to display settings, for instance, if I want the background to be gray. The next two control sets that make up the control panel is the view information and the information box. The view information consists of two parts. The top part is an alternate set of view controls that let you control the view of your model without actually directly moving the mouse into it. For instance, I can rotate the model here, translate it here, and rotate it right to the right. Basically, the exact same mouse controls I have by directly moving the mouse in the window I can use here instead. I can also reset the plot by clicking on this button, rotate it by either moving these dials or clicking these buttons. This allows me an alternate method of interacting with the model that is sometimes handy when you're doing interactive manipulations or if you've forgotten what the mouse and keyboard controls are. Once you've remembered the mouse and keyboard controls, I generally tend to leave this minimized. Down here is the view information, which gives you the detailed information of exactly what the 3D view settings are, in case you need to recreate them later. Lastly is what we call the information box. You'll notice as we move the mouse over the model, information on what's going on directly under the mouse circle appears there. The ball ID number, its center, its radius, and its position and the position in space of where the mouse cursor intersects that ball is displayed every time you move the mouse. This is extremely handy for quickly getting information about your model back from a plot. Up in the top, in the context-sensitive toolbar area for plot panes, you will see a region of tools we call the mouse modes. By default, we are in the manipulate mode. This means that if something is manipulable, you will be able to grab it and interact with it, like the legend. However, if you press and hold the Shift key, you automatically drop out of manipulate mode into view mode. This allows you to change the view of your model even if you are in the process of manipulating something. However, you can, if you wish, go into view mode, and that eliminates the possibility of doing any manipulation of the model behind it. There are other view modes available. This is target mode. As you can see, when over an object that the plotting logic recognizes, it changes to a target. And what that does is it changes the view center to the object under the cursor so that you can zoom with the mouse wheel directly in on that object and then rotate around it. This is helpful for zooming in on objects of interest when you're plotting. This is a distance measuring tool. I can make a mark at one point in the plot, another mark at a different point in the plot, and it brings up a dialog showing me what the beginning and ending points are, the distance between them. And if I wish, I can log that information to a file and save it for later. I also can make a plane measuring tool, or I can mark 3 points in space to log a plane. Now you can see I can add that information to the last log file I created, create a new log, or just hit OK. Lastly, there's query mode. When the mouse cursor is over an object it recognizes, I can bring up an information box on that object. So for instance, here is a great deal of detailed information on ball 1407, including its position, its velocity, its radius, and its damping, its mass, including the list of contacts it has with other objects around it. I can even click on one of those contacts and get detailed information on that contact, including the two entities it's in contact with. I can then go and click on that contact to see it's in contact with ball 9528. I can continue to follow that chain of information as far as I want, or back up to get back to where I started. All the while I can log any of this information to a file, and then make another query later on.
Now I'd like to focus on the plotting capabilities of PFC3D, which is really the main feature set we've added in this new release. So far you've seen the ability to plot balls and walls. We can also plot other objects that are considered part of a PFC model. For instance, if we go to the list, we can plot contact geometry. The blue areas represent the locations of contacts. If I go to the ball plot and make the balls transparent, I can see them clearly. I can actually go to the contact geometry plot and make them 25% of their radius. Now the locations of those disks correspond to the locations of contacts. I can go here to the icon settings and change those to cylinders. Now they are cylinders connecting the balls that are in contact. By clicking on this All Contacts option, I can see both active and inactive contacts. Inactive contacts are contacts that exist and are tracked by PFC but aren't carrying any force at the current time. I can also plot contacts as spheres at the point of contact. I can also plot the location of parallel bonds. The blue represents the location of parallel bonds. I'll shrink them down a little for clarity. You can see where the parallel bonds exist between balls and how they are making clusters. Lastly, I can use the contact plot to show contact force chains. Let me change the auto scaling a little to make things a little clearer. Now, those cylinders represent the forces on the contacts, and their thickness represent the force magnitudes. Blue is compression and green is tension. One of the other features of PFC3D is that just about every plot has the ability to map and shrink the things it's plotting. For instance, if I add a new ball plot item, in this case, a contour of the velocity magnitude of the balls, by default that's going to plot over the top of the ball plot I already have. But I can choose the map attribute and map it 50 units to the right. This allows me to see both the new plot item and the old plot item at the same time. I can also, for instance, choose the shrink factor to shrink those balls to half their original size, perhaps to indicate that those aren't the actual location of the balls. I'm just using them to indicate the magnitude of their velocity. One of the more powerful plotting features of PFC is its cut planes and clip boxes. Here I'm back to the caving example, and I'm plotting a contour of ball density, and I've assigned a slight gradient to the ball density just so that you have something to contour. I can go to the plot item list, and at the bottom of the list of plot items, are cutting planes and clip boxes. Opening up the cutting planes, I have a list of the available cutting planes. And here I'm going to select a simple plane. As you can see, we immediately orient that plane perpendicular to the view and cut the balls. It's actually calculating the geometric intersection of all those balls with the cut plane and showing you the result. You can see the result as disks. Now if I go into the ball plot item, I can choose how that plot item interacts with that cut plane. For instance, I can say I want to see all the balls in front of the cut plane as well. A simple cut plane is only one of the options. I can do a wedge, for instance, to display a cutaway view. Or even an octant. Let's go back to a simple plane. Any number of cutting planes may be superimposed on the same plot. So I can open another ball plot of density. I can create a new cut plane in a different orientation and choose to make the second ball plot aware of the second cut plane. So I can see the result of both at the same time on the same plot. I can have any number of cut planes available in a given view. Any given plot item can only be aware of a single cut plane. Another option I have for restricting what's being plotted is what's called a clip box. This does not actually calculate the geometric intersection. Instead, it simply restricts what's being plotted at a pixel level. Here, I can increase the field of what's being rendered by grabbing these bars, or I can grab it and move it through the field of view. Because it's interacting directly with OpenGL, it can operate very quickly and in real time to let me scan through the model and see it in sections.
Sometimes you don't want to plot the entire model, you want to plot a subset of it. When you wish to filter part of your model, in PFC you use the range logic. Here, if you click on this icon for a given plot item, you activate the interactive range dialog. This comes up as an overlay on the control panel. Here I can select a given range element, in this case sphere, and I can interact with that directly on the plot. For instance, change the sphere radius and change the sphere's location. A given range is by default the intersection of its range element, so I can add another element, let's say a plane. In this case, all elements this distance away from a plane in space. And I can see how I'm doing the intersection between a sphere and a plane in space. Now when I press OK, I'm only plotting those spheres in that range. If I want, the plus indicates that there is a range active on that plot item. I can go back to the range dialog to edit it and change it any way I want.
As I said, while in manipulate mode, you can directly interact with plot items if they support such manipulation. For example, the axes plot item, here in utility model, will allow you to position and size the axes by direct interaction. Also, if we create a new plot, the various chart plots, in this case a history, this is a history of unbalanced force or mean contact force. This chart can be sized, moved, and you can focus in on a particular area of the plot interactively. You can even use the mouse to zoom in and out. PFC3D also gives you the opportunity to plot things that aren't actual model objects. As an example of which, for instance, you can import DXF files and superimpose them directly on your models. I'm choosing DXF, clicking here on the File button. I'm going to pick a particular DXF file. I'm going to color that in a lighter color. Get rid of the wireframe. This is an example of an open pit that we can superimpose on our model if we want. We can also use the mapping in case that it uses a coordinate system that's different than what we're using for our model. In addition, we can use fish plotting. In this case, we have an array of fish functions that have been identified. Here, for instance, is a fish function called circitem that plots some circles and some lines. We pick that here, we can see the results. So we can write quite elaborate fish functions if we want and superimpose whatever we want on top of our plots to aid in visualization. And lastly, I'd like to cover the movie feature of PFC3D EV. Movies are generated differently than they were under the old version of PFC3D 4.0. We no longer generate AVI files internally. Instead, we generate PNG frames and allow you to assemble them into movie files yourselves. This allows us to generate many movies at a time from a centralized location. For instance, here we have the ball mill project provided as part of the PFC distribution. I've generated 3 views, a base view that just shows the ball and wall geometry, a force view that shows the wall and ball contact chains, and a velocity view that shows ball and walls color contoured by velocity. If you go to the tool menu, I can bring up the options. And here in the movie tab, I can see highlighted all the movies together. I changed the movie interval to be 100. We're going to be generating PNG type bitmaps at a size of 1024 by 768. The prefix is movie. This means that all the files generated will start with movie underscore, then it will be the name of the view, then the index number, and then the PNG postfix suffix. The checkmark indicates that all 3 of these views will have a movie taken up them, so the movie is active. Now, if you execute the ball mill data file, and let it cycle for a while, we can watch one of these views as it's cycling. Now I'm going to stop it just for illustration purposes. And if we go to the local directory and explore, we can see all the files that were generated by PFC. If we click on one of those files, we can see they were generated in sequence automatically. Now we can bring those files into any movie creator to turn them into a movie, edit them, remove frames, do whatever we want. I recommend QuickTime Pro for this purpose, but even Movie Viewer that's supplied with Windows would work fine. This concludes our demonstration of PFC-EV. Thank you for your time.